Hey everybody, welcome to the last unit that we're going to be covering this year as we finish out the school year and our remote learning. Well, there'll be a couple lessons, but this is going to be the last chunk of content we do. And the last chunk of information that we're going to be encountering is solving systems of equations. A system of equations is simply a collection of two or more equations. So earlier this year, we've solved equations, single equations, and we're going to finish the year by solving two equations at the same time. The first method that we're going to use is called substitution. And it's called substitution because our first step in this process, what we're going to do is we're going to substitute information from one equation into the other. So for substitution, the first thing we do is we're going to substitute information from one equation into the other. So let's take a look at our first equation, system of equation. So we're being asked to solve this system. Okay. Now, what we have is two equations that are set equal to y. So one way of thinking about this is that the 3x plus 25 is equal to y. Well, we have a y in this other equation here. And since 3x plus 25 is equal to y, what we can do is substitute that information into the y in the other equation. And this is our first step, step one. Substitute information from one equation into the other. So when we do that, what we get is an equation looking like this, right? 3x plus 25 equals negative 2x plus 5. Step two, we're going to solve the equation. So we've solved equations looking like these before with variables on both sides. So what we're going to do is we're going to get the variable on one side. And the way in which we will do that is I'm making the decision to eliminate the variable on the right-hand side by adding 2x to both sides, because this is a negative 2x. So we add 2x to both sides, which eliminates the x on the right-hand side. 3x plus 2x is 5x. And so now we have a very familiar equation that you guys have solved many, many, many times throughout this school year. 5x plus 25 equals 5. So we're still on step two here. So step two is continuing. We're still solving this equation. And so we're going to get rid of this plus 25 by subtracting 25 from both sides. That's going to give us 5x equals negative 20. And then lastly, we'll divide both sides by 5, which is going to give us x equals negative 4. So that was all step two. Step three, what we're going to do is we're going to substitute this value that we just obtained into either equation. So either of these two, we're going to plug x equals negative 4 into either one of these two equations, and we're going to get the value for the other variable. And so you only need to plug it into one equation. However, I want to show you that it doesn't matter which equation you pick, okay? If you did the math right and you plug negative 4 into either of the two original equations, what you can see is that they produce the same value. And so this shows you two things. One, it does not matter which equation you plug your first value in for. And secondly, this shows what it means to solve a system of equations. What we're figuring out is what value of one of the variables produces the same value in each equation for the other variable. So we found that if you plug negative 4 into both equations, they both produce the number 13. And that's what it means to solve a system of equations. So that's step three right here. And then our last step is to write our answer as a point or an ordered pair. Our x value was -4, and our y value was 13. And so this is our fourth step, which is just writing our answer like that. We'll do one more that looks like this. I'm going to stop the video, and then I'm going to show you a slight variation, and just to break up the video into two parts, okay? All right. So we're going to solve the system. If you'll recall from the previous problem, and hopefully you're pausing the video and taking notes and writing the steps down, we're going to take information from one equation and we're going to substitute it into the other equation. So just like before, this information 4x plus 10 is equal to y. So we are going to substitute that into the y into the other equation. And that's going to give us 4x plus 10 equals 2x plus 16. Step 2 is just to solve that resulting equation. We have a variable on both sides of the equation. So we're going to eliminate one of them. 2x minus 2x eliminates the x on the right-hand side, leaving us with 2x plus 10 equals 16. Once again, this is very familiar territory for us. So to get rid of the plus 10, we're going to subtract 10 from both sides, which gives us 2x equals 6. We're still on step 2. And we're going to divide everything by 2, and we get x equals 3. And that's the conclusion of our second step. So we've now solved that equation. The next thing we're going to do is we are going to take that value that we just found and substitute it into either one of the original equations. If you'll remember from the previous example, it does not matter which one you use. It will produce the same value. So we're going to plug x equals 3 in for x. 4 times 3 is 12. 12 plus 10 is 22. So we've now found the other value. And our last step is to take our x value and our y value and write our answer as an ordered pair, or a point. All right, folks, so that's it for this video, and I'm going to post a second video on how to handle a slight variation when solving systems of equations by substitution. Thanks for watching, and I hope everybody's safe and well.